Hi everyone, today we are starting section 3.3 of integrated 3 KC3. So this is a discovery activity that you guys got to work on in class before I actually taught it. Okay, so you guys, the point of this was for you to see patterns when you graph certain functions. So for the sake of the notes, we are going to focus on quadratic functions, which, if you remember from Unit 1, are functions that have an exponent of 2. But this can be applied, everything that you learn here today, or the patterns that you see, can be applied to any function, to any cubic function, any function to the 4th, 5th, 6th power, and so forth. Okay, these are just on transformations. So the first part that we're going to do, and we did this together in class, we did part 1 and part 2, and then you guys had 20 minutes to finish the rest. So part 1 is to determine the quadratic parent function and what that looks like, okay? Now, a parent function is just your function, like f of x is equal to x squared. When you're not adding anything specific or subtracting anything, it's just a variable and it's just the exponent. Okay, so you guys already know what that looks like, okay? An x squared function, remember, has a vertex right here in the middle, and it curves up, and it looks like a U. Okay, so this is a parent function. So all of your functions start from here. Then you transform them. So you either move the graph to the left, to the right, up or down, you reflect it, anything like that. Okay, but in general, you start with your parent function, okay, which again will be x squared, and your graph will look like this. Now, the vertex of this parent function is where it starts to turn right here at the middle, which is my origin. My coordinate is 0, 0. Okay, so we're going to start this, or we're going to complete this activity with this in mind, that our parent function, our general function, is x squared, and it looks like a U through 0, 0. Okay, now the second part of this, I did post a link to Desmos, which is a graphing calculator site, so that you are able to see this visually. So what I want you to do is I want you to compare both functions. And what I mean by both functions is I want you to compare the parent function, f of x is equal to x squared, and the new function that I give you. So you're going to graph those in Desmos, and you're going to sketch what that looks like and give me the vertex. Okay, you should then be able to describe what happened with the vertex. Okay, for example, did the vertex shift left 8 spaces, or did it move 8 spaces to the left, or did it reflect or flip over the x-axis and whatnot? Okay, so we're going to go ahead and do number 1 together. So f of x is equal to x squared, and g of x is equal to x squared plus 5. So I'm going to go to the Desmos site, and I'm going to type both of those functions in. Okay, so I have x squared is one of them. And the second one was x squared plus 5. Okay, so you can see my first function, x squared, is my red line, and x squared plus 5 is my green line. You can see that it moved from the origin, my vertex, from 0, 0, it moved up to 0, 5. That is what we want to see. Okay, so I'm going to go ahead and sketch this. I'm going to say, like, this is my parent function right here. I'm going to use the red one. That was the original parent function. And now, after adding this 5, it went up 5 spaces, and now it looks like this. Okay, so now my vertex went from 0, 0 for my parent function to 0, 5. Now the description, it says, how did the location of the vertex change between f of x to g of x? The only thing that it changed was that it moved up 5 units. And that gave me my new vertex. Okay? So let's do another one. So I have x squared and x squared plus 3. I'm going to go back to Desmos, and I'm going to change this to 3. And again, I can see that my graph still went up, but it's not at 5 anymore. Now it's at 3. So I'm going to go back here, I'm going to draw my new one, which would be somewhere here. My vertex is now 0, 3. And all that happened to my vertex was that it moved up by 3 units. Okay, so I want you to go ahead and pause this video and finish the rest of these before I do. Okay, so on number 3, I have f of x is equal to x squared and x squared minus 7. So what happens here is it actually goes down here somewhere at 7, at 0, negative 7. So this one moves down by 7 units. Now question number 4 says, in general, how does the k value change in the graph? Okay, so how does adding or subtracting these numbers change or move my graph? Okay, so my k value moves my graph either up or down. Okay, it says what happens when you add or subtract a number on the outside of the equation. Okay, so if you go up when you add something, right? Like in the first one we added 5, the second one we added 3. The third one we subtracted 7. So when you subtracted, we go downward. Okay, so that's something to remember. What's important here is that the only thing you see is a number outside of your variable. Okay, now I want you to go ahead and pause the video again and plug in these next 3. Okay, now these are a little different. Okay, if you notice, you have parentheses here. So that's actually going to change your graph and how it looks. So go ahead and pause that video, do these 3, and complete your notes. Okay, so if I go to Desmos, okay, I'm going to go ahead and plug in my new function. I had parentheses x minus 5 squared, and that's it. Okay, so now instead of going upward or downward, it went to the right. Okay, so I'm going to go ahead and type that. My new vertex now is 5, 0, and it moved to the right at 5. Okay, now, so this moves right by 5 units. Again, finish the other 2 if you haven't already, but you will notice that the vertex for number 6 would be negative 3, 0. So it's over here on the left. So it moves left 3 units. And the last one is at 7, 0. So it moves all the way over here. And it moves right 7 units. Okay, so now on this table with the h value, how does that change my graph? Now before with the k value, we went up and down. Now with the h value moves the graph either left or right. Now, what does that depend on, right? So on here, let's see. The one that moved left was my middle one, number 6. It moved left, but inside of the parentheses, you can tell that I was adding something. So to move left, you have to add something. And to move right, you would have to subtract something. Now, I know that, you want to, that adding something usually means moving to the right, and subtracting something usually means moving to the left, which is true. However, this is in parentheses. So when you have something in parentheses, remember that you have to do the opposite. Just like when we were solving our zeros, right? If we had x minus 2 in parentheses, it was the opposite of that, okay, when we were looking for our zero. So this still applies here. So you need to remember that. If it's in parentheses, you actually do the opposite of that. The next ones are the a value. Okay, so if you go ahead and pause the video, finish the next 3, before I complete this. Now the vertex to number 9 does not change. Actually, the vertex to all of these do not change. It stays the same. The only thing that happens is that your graph will look something like this. So what happens is that your graph shrinks. That's it. This shrinkage or shrinking something is a dilation. Okay, think about dilating your eyes, right? When you go to the doctor and they dilate your eyes, they expand or contract. That's exactly what's happening here. Okay, so for 5x squared, you'll get the same thing, except it's a little skinnier, it's a little narrower. And then at number 11, you have 0.2x squared, and what happens here is a little different. It actually looks something like this. So instead of shrinking here, it actually widens the graph. Now, why do you think that is? Okay, so you want to ask yourself that. So if I change my A value, how does that change my graph? So my A value actually shrinks or widens my graph. Okay, it will shrink, right? If you notice, I have 2 and 5. They're whole numbers, but they're actually bigger than 1 when A is greater than 1. And it will widen when it's between 0, not equal to, between 0 and 1. So you're looking for a fraction here, or a decimal that's smaller than 1. Okay, when that happens, you will get a wider graph. And last but not least, when you have a negative A. So if you go ahead and plug this into Desmos, the only thing that you will see is that this flipped over. My vertex is still the same at 0, 0, but it just reflects or flips over the x-axis. Okay, so in general, what happens to the graph with the A value is negative. That's it. It just flips over the x-axis. Okay, so out of all of this, these are your key ideas. Okay, a negative in front reflects. Right, you just did that right above. What else? If you have, if you're adding, if you add or subtract outside parentheses, you will go the graph goes either up or down. Okay, and the last one is that if you add or subtract inside parentheses, your graph goes right or left. Now be careful. The only thing you have to remember here is that you do the opposite. Okay, so if it's positive, you go left. If it's negative, you go right.